I know we did 4.6 last class. I'm going back to 4.4 and 4.5 for this class. So before you keep going with the video, just make sure you do have the classwork in front of you. It should look something like this. I think the sub has it, but if they don't, then it should be in the corner. You can grab that. So we're just doing day 1 today. We'll do day 2 next class, and then we'll pretty much, wrap up with maybe a PSAT day to finish out the week. But I kind of just wanted to give you this warm up because it's quadratic, the stuff we've done before. So you have these 6 parts. So what I want you to do is pause the video and just use your graphing calculator if you want to. You don't have to do the negative b over 2a calculating and stuff like that. I mean, you can if you want to, but I'm telling you don't need to. Just use your graphing calculator and try and interpret what's going on in this function, using these questions. All right, so if you did this, we can graph it ourselves. It's negative 16t squared plus 24t plus 7. So here, go to negative 16x squared plus 24x plus 7. Get yourself a good window. It's a free throw that's being shot, so I don't need negative time. I don't really know what's going to happen. Yeah, we'll stay with 10 seconds, but that's pretty long. I don't need it to go, below 0. Maximum height for a basketball, I don't know, maybe 20 feet. And we'll see what this looks like. All right, so we have this graph right here. So question A, how high does the ball get? Just do maximum if we want to do it that way. Or if you did negative b over 2a and then plugged it in, you could have done it that way. Let's see what we get here. All right, enter. Right bound, enter, enter. All right, so we have a maximum of 16 feet, right? So how high does the ball get? 16 feet. Oops. All right. How long does it take the ball to hit the ground, assuming it does not touch the backboard of the rim? Maybe even the net would slow it down enough, but it might be an air ball. But how long does it take for the ball to hit the ground? Right, so that would be the height at 0 feet. So if this is my y-axis, 0 feet would be on the ground. So I can do the 0 button and just left bound, right bound. Oops. I got a positive y and a negative y. That should do it. 1.75 seconds. So 1.75 seconds. What is the initial height of the basketball? So just the starting height. So if I plugged in 0 for t, that'd be the starting height. So that would just be 7 feet. Again, if you did it on your calculator, you could just hit the value button and type in x is equal to 0. Get 7. So 7 feet. Where is the ball 7 seconds after its release? So at a time of t is equal to 7, so I can hit value, and x is equal to 7, I get negative 609, right? So this is kind of where the interpretation of functions in this lesson, more so tomorrow, comes into play. After 7 seconds, right, this isn't necessarily the pathway of the basketball. I mean, it is if it hits an air ball, but only up until 1.75 seconds. Then it's probably going to bounce a little bit, and then you can assume after 7 seconds, it's just going to be on the ground somewhere. So ignore the calculator, right? There's certain things that calculators cannot really do if you just have a common sense approach. So where is the ball going to be after 7 seconds? It's going to be on the ground, right? So at 0 feet. Maybe somebody picked it up and shot another shot. Okay, maybe, but for this purpose, let's just assume nothing happened to the ball. It just hits the ground and rolls. 0 feet, right? Over what interval is the basketball increasing and decreasing? So it would be increasing, do I for increasing, from here to here, right? So we got the vertex before. You can hit the maximum button, but it was 0.75 seconds. So it's basically increasing from 0 seconds to 0.75 seconds because we're going to use the x coordinate. So 0, comma, 0.75, so interval notation. And then decreasing from that 0.75, but we're not going to say to infinity, because again, keep it in context of a real world problem. It stops decreasing at 1.75 seconds, right? And we don't know the bouncing, how high it gets when it bounces, so we're just going to stop there because that's all that we know. So from 0.75 to 1.75, and that's it. We're not going to go to infinity because it hits the ground. And then last but not least, label each A through C as a characteristic. So how high does it get? That would be our max value. Same thing as the highest y coordinate. Part B, how long does it take for the ball to hit the ground? Right, hopefully you got that. That's the next intercept. Right, when y is equal to 0, or in this case h of t is equal to 0, that's the next intercept. The initial height of the basketball, right, that would be our y intercept, right? At t is equal to 0, x is equal to 0, you have a y-intercept. Right, so we're done with the warm-up. So we're just going to talk about some other things we can describe on a graph. We have increasing, decreasing, and constant. I think we've already talked about this year. But basically, right, if you have this graph, it's increasing. So it's, you read graphs like you read books from left to right. So if it's going up from left to right, it's increasing over that interval. If it's not, it's what we call constant. If it's going down from left to right, it's decreasing, right? So you wouldn't read from this point to this point and say that it's increasing because that's reading from right to left. You don't do that with graphs. So increasing we have from 2 to 4, right? We're always going to use parentheses for increasing, decreasing, never brackets. It's decreasing from -2 to 0. Right? So always giving me the x coordinates. The y coordinates tell me that it's decreasing. You don't need to say that. And constant from 0 to 2. Right, this one right here is x cubed. Kind of looks like it's almost constant there, but it's definitely going up. You know, think about 0.1 and -0.1 to the third. You're always going to be increasing here. So it's increasing forever, so it's negative infinity to infinity. And decreasing never or none, whatever you want to say. Or not applicable, whatever. All right, increasing, this is going to be going up and up and up, all the way from negative infinity, all the way from the left, until we hit what we call here is called a relative max, right? It's not the overall max, because the overall max is going to be infinity, but this is what we call a relative or a local maximum. Let me just write that, relative or local max would be right there. And then obviously right here would be a relative or local minimum. So we're increasing until we hit that relative max, so negative infinity, 2. Again, I don't care about 2, just want the -1. And then you can see here we're actually decreasing, so but we're going to increase again after the local minimum or relative minimum. So I'm going to hit a union, and then we're going to increase again from 1 to infinity as I keep going to the right. 1, infinity. And then we're decreasing simply in between, right? This is the only part where my graph is going down from left to right, so it's -1 to 1. And if you notice by your answer, everything is covered, right? You're negative infinity to -1, you're 1 to infinity, and then you're in between from -1 to +1. There we go. And that would be it. And then there's another thing we can call positive and negative position. Basically, it's just telling me where the y values are positive and negative. That's why we call it positive and negative position. So like if you look at this one, this between -2 and 4 is where the whole graph is. But the whole thing has positive y values. So this whole thing is what we call in positive position. Now, I'm not going to say negative infinity to infinity because the graph only exists between -2 to 4. So I'm going to say between -2 and 4, it's positive position. But there is no negative position. So never or none, or however you want to symbolize it. But there's nothing, right? Now here, I'm positive position. So all the way, everything from down here is what we call negative position because it's below the x-axis. They're all negative y values. So I'm positive from 0 to infinity. Anything where x is positive, I'm going to be positive position. So I'm going to put 0 to infinity here. And then negative position is what I highlighted in red. So I'm not going to say 0 to negative infinity. I'm just going to say it from negative infinity to 0 because you want to start with the smaller. And then here, positive position, right? So, well, this is going to be negative. Anything below the x-axis is negative. So these are all my negatives, and everything else is positive, right? And that's all you need to separate it. So I'm negative. I'll just do negative first. I'm negative from negative infinity, all x values, over here. Negative infinity up until I hit, I mean, I could find out what it is, but it looks like, negative 1.7. I'll just ballpark it here. Negative infinity to negative 1.7. And then I'm also negative again from 0 to 1.7. So that's where my graph is in negative position, or basically below the x-axis. And then positive position would be everywhere else. So between the negative 1.7 and the 0. And then again between, or from basically the 1.7 where I terminated it here, all the way to infinity. And again, you can look at your answer and just see that everything is covered, which is good. And that's it. All right, so the other thing for today's lesson is we're going to describe some things about graphs, where it's increasing, where it's decreasing, where there's positive position, where there's negative position, and all the other things we've done before, intercepts, and things like that. So with tables, we're a little bit restricted because we doesn't have a perfect picture of what's going on. We don't have an equation to work with. We don't have a graph to work with. So you kind of have to be able to dissect the table. So if you think about where the intercepts are, you can pause the video and see if you can find those, and then just kind of keep pausing on along the way as I go through these problems. But like here, right, my intercepts, anytime you see 0, you got an intercept. So I got 0, 24. That would be an intercept. And then if you see another one, 11, 0, that has to be another intercept. And those are my 2 intercepts. Right? I don't see any other zeros. So 0, 24, that would be my y-intercept. And then 11, 0, that would be my x-intercept. I don't really see anything else. Anything about increasing and decreasing position, we want to look for the y's. See where the y values are increasing or decreasing, and that'll tell us when the graph is increasing and decreasing. So you can see, right, all of my x's are in order, which would be much more difficult if they weren't, but they start with negative 10, go up to 16. So just look at what the y's are doing. 12 to 18, all right, it's going up, it's going up, it's going up, it's going up. Okay, boom, it's going down. So once I hit this 27, I started going down. So I'd say I'm increasing from, again, we only worry about the x's. Looks like, negative 10 to the 3, 27. I was increasing until I hit that. And then I'm decreasing, starting with that 3, 27. After that, I'm decreasing. So notice how they both have the 3 in common. All right, let's see where I decrease to. So 27, 19, 7, 0, negative 5. Okay, so all those went down. Negative 4 is actually going back up. So here, from 3 to 15, the graph was going down. It went from 27 to 19 to 7 to 0 to negative 5. So I'm going to put 15 here. And that would be my decreasing. But then I'm increasing again. From 15 to 16 goes from negative 5 to negative 4. So that actually need to add a u here and put 15 to 16. And that'd be where I'm start increasing again. Now again, could it be maybe increasing between 0 and 3? I mean, decreasing goes from 24 to 27. Yeah, that's why we're a little restricted with tables. But based on this, that's what I can see. And I've never put any infinities here with tables because I don't have anything bigger than 16 or less than -10. I'm restricted to what I see. Positive and negative position, right? If I think about that, look at where your y values are positive and negative, right? So even though I'm going up here, it doesn't really matter with positive and negative position. I'm just looking for positive y's. So here, 12, 18, 22, 0, 24, right, 27, 19. I don't care that I'm started going down. It's still positive position. So I don't hit negative position until I hit the -5, right? So 0, 11 comma 0, that's going to be my cutoff. So I'm basically positive from -10 again, just giving me the x values here, to 11. And when I hit 11, I'm at 0. And then basically I'm negative position between that 11 until the 16. And that's all I can do. I mean, yeah, it could be positive between 11 and 15. It might not go from 0 to -5 directly. It might go up to 3 and then down to -5. We don't know, but based on the table, that's kind of what we have to kind of conclude. And then relative maxes and mins. So if you think about that, that's where I had like the local, so this was a relative max, this is a relative min. So where the graph is changing direction, right? It went from up to down, and it went from going down to up. So I can pick those out, and again, it's based off my increasing and decreasing positions. But again, it's 12 to 18 to 22 to 24 to 27, and then down. So it went from 24 to 27, and then after 27 went down to 19. So this is going to be, use a different color, but this is going to be 3 comma 27 would be the relative maximum, right? That is the highest spot I have relative to the other spots. So 3 comma 27 would be a relative max. And then I'm going down after that, 19, 7, 0, -5. All right, so now it changes direction again. It went down from 0 to -5, and then it actually went up from -5 to 4. So 15 comma -5, so this would be the max here, or one of the relative max, but there is only one. And then a relative min would be 15 comma -5. And if you look at those numbers 3, the x coordinates, 3 and 15, those are what pop up in here, right? The -10 and the 16 is just where the data stops, so that's kind of it. But the 3 and the 15 are obviously where the graph is changing direction, so it's going from increasing to decreasing, and it's also indicative of a relative maximum. All right, so in partners, or it's kind of a video, so if you want to just do these ones on your own, just kind of label intercepts, increasing, decreasing, positive, negative position, relative maximums for the following. If you are in partners, you can just talk about them with number 1, and you can actually do them with 2 and 3. Number 4, you can just kind of observe it and figure out what it would look like, but that's it. All right, so number 1, intercepts, anywhere you're crossing the x-axis, intercept. 0, 0 is also the y-intercept. So intercepts, intercept, intercept, intercept. Increasing and decreasing, right? You're decreasing and then increasing. Right? I don't want you to write down all of these. That's why I said just observe it, because there's a lot of them. But just kind of be familiar with what you're seeing. This one's always increasing, always decreasing here. And then, decreasing to increasing to decreasing, and then kind of stops. Positive and negative, right? Positive, 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 and positive. Everywhere else would be negative. Maxes and mins, the local ones, right? So we have here, here. You could even say this would be a relative min and this would be a relative max. Same thing with these two, I guess. But it's mostly the ones where your graph is changing direction. So these ones would probably be the better ones. Maybe here if you wanted to include that one, or here if you wanted to include that one too. Now with the second one, what we have is kind of a table. So intercepts, you can see an intercept right here at 0, 1, 1, 0. Certainly intercepts there. You could see there's probably another one in between here. If it goes from -3 to 2, assuming it's continuous, you're going to have another intercept in between there somewhere too. But you just don't see it here in the table. But again, if you think about increasing and decreasing, right, I'm certainly decreasing, 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 decreasing. I'm sorry, increasing, going up, 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 up. And then right here at -1, 2 would be like a relative minimum. Because after this point, I'm sorry, relative maximum, because after this point I actually start going down again from 2 to 1 to 0. And then again at 1, 0, that would be a relative min, because after that I actually start going back up. So you kind of see the pattern. We're increasing until we hit 2, then we start decreasing until we hit 0, and then we start increasing again. So those are kind of increasing and decreasing, and the maxes and mins there. And then positive position, right? Basically anything from here is positive position, and then anything up here is negative position. 1, 0 is, I guess, neither, but that would be a relative min, so that's where you'd kind of cut it off. Non-calc, 1 over x minus 3 plus 2. You find the the y-intercept by plugging in 0, so you get 1/3 plus 2, which would just be 7/3. And then you can get the x-intercept by setting this equal to 0. So hopefully you did it, but if you subtract 2 and then you multiply by x minus 3, you get 2x minus 6 is equal to 1. So you would get an x-intercept, I believe, of 5/2. Right, when you add the 6, and then, let me think here. Right, so we'd have -2x plus 6. Yeah, that's what you get. You should get 5/2. So those would be 2 intercepts. You think about this graph, it's basically right 3 up 2. If you think about your asymptotes, right 3 up 2. So that's kind of like, you have a vertical asymptote at 3, horizontal asymptote at y equals 2, and then your graph should look like something like this, with arrows on the ends. But if you look at it, it's actually always decreasing. You never have any increasing intervals, so it's decreasing from -infinity to 3, union 3 to infinity. You don't include 3 because there's no graph there. And then positive position would basically be wherever you found this, it would basically be -infinity to 5/2, and then after, the 3, it's everywhere. So union 3 to infinity, and negative position from 5/2 to 3, and that's it. And then this one, when you did graph it, we have 5 sine x of 2x minus 2, right? If you did graph it, 5 sine x, and then what we have, 2x minus 2. And then we complete everything else. Probably also want to be in radian mode here in case you weren't. But if you think about this one, right, this one would be, again, I would never ask you to write all these things down. But, you can just kind of see, relative max, relative min, relative max, relative min, decreasing, increasing, decreasing, increasing, positive position, negative position. Just be able to see it and identify it from a graph, and you should be in good shape. All right, so last thing we're going to do is just comparing functions. So with this one, I just kind of want you to compare these. So you can pause the video and then resume it when you're done. Finish these comparing and contrasting. Hopefully you found some things if you think about it, right? If we notice that this first one is -1.5, okay, but it's left 3, up 7, right? That would kind of be the vertex of it, and then it's just stretched and reflected, vertically stretched and reflected over the x-axis. But if you think about it's left 3, up 4.7. It kind of resembles this one, it opens down because of the negative, and then it's vertically stretched, which might be harder to tell because it's only 1.5. But if you wanted to plug in your own points, like so, start by figuring out these things, right? Increasing and decreasing, right? So, well, if I plug in 0 here, I get 1.5, things like that. But, an easier number to plug in might be, 1, right? Because if I plug in 1, I would get 1 plus 3, which is 4. Square root of 4 is just 2. So negative 1.5 times 2 would be negative 3 plus 4.7. So, I plugged in 1 and I got, I lost my train of thought there, but 1.7, which is kind of what I have here. And then I actually have it right here on the graph here. If I plug in 1, I get 1.7. If you noticed, and hopefully you did, all of these things are exactly the same thing. Positive and negative position, you can compare these two. Basically, you're always positive here, and then up until 4, you're actually always positive. But these graph kind of mimics the same points you'd have here. Negative 5, negative 4, it doesn't exist. Well, negative 5, negative 4, it doesn't exist. And here, if you plug in negative 5 and negative 4, you can't, because that would give you something that's negative under the radical, which you can't, so it's not even in the domain. So these are actually all the exact same things. And then the last one we're going to do is this. So comparing and contrasting. Again, if you have a partner or just work with the people around you, compare this chart with natural log of x, and you can use your calculator if you want to and see what you get. And then do number 2 as well, in which case you're comparing this one with this one. So again, take a few minutes actually. I kind of want you to see if you can find the relationship that both of these share with each other, and then resume the video and see if you got it right. All right, so if you think about this, natural log of x, you can graph it if you want to. But if I just did natural log of x, right, I get that graph, and you could actually use the table feature and get the points on the table if you wanted to. But if you think about these, right, this one I have, let's look at the intercepts. So I have 0, 1 here. I have 0, nothing. It doesn't exist. I have 1, 0 here is the intercept. So that's interesting. My intercept here is 1, 0. Here it's 0, 1. I can't plug in 0 here. If you notice, I don't exactly get 0. I get pretty close to it, but I don't get it. I get closer and closer to 0 as I keep going further and further negative. Here, get closer and closer to 0 as I keep going negative, but with a different axis. If you think about 1, 2.718, here I have 1, 0, but I actually have 2.718, 1. So if you found it, great. It's kind of a harder find, but this graph and this table are actually inverses of each other. All the coordinate points are flipped. So like negative 1.36, it's actually 0.36, negative 1. So these are inverses of each other, which if this is natural log of x, that means this data table is e to the x. On this one, if you did it already, you got negative 2, 0. So I look for intercepts first. Negative 2, 0. 0, 0, 0, 0. 2, 0, 2, 0, right? So this could be the same thing again. Here, right, I'm increasing, increasing, increasing until I hit negative 1, 3, right? Well, here I don't have negative 1, 3, right? So it's not the same graph. But I'm essentially increasing, 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 increasing until I hit here. This one's initially, right, negative 5, I don't have it, but negative 3. It's decreasing, decreasing, decreasing until I hit somewhere around that negative 1. It's not positive 3, it's negative 3. But it's kind of like it's doing the opposite so far. And then from negative 1, 3, I actually decrease here. And then, but from here, from negative 1 to 1, I'm actually increasing. And then over here, 2, 0, right? So, I got 1, -3. So to 0 increasing, to 15 increasing, to 48 increasing. But at my 1, I actually start decreasing afterwards. So if you found the relationship, great. If you think about positive position, it's actually the opposite. These are always going to be opposite each other. I'm negative infinity to -2 for positive, and then union with 0 to 2. If you think about this, negative infinity to -2, or -1, oh yeah, no, -2. That's where I'm actually at negative position. And then between -2 and 2, I'm actually here. -2, I'm sorry, not -2, -1, yeah, no, I'm right. 0 to 2, I'm also positive. 0 to 2, I'm actually negative, although that's the only point you have. And then anything after 2, I'm negative. Anything after 2, I'm actually positive. So these two are actually reflections over the x-axis of each other. They're simply, one of them is a negative. Like if you just flip this one upside down, it would be this data table. So if you found that relationship, great. And then a quick summarizer, if you want, well, no, still do it, but draw a graph and try and make it continuous and, not necessarily a piecewise, that has negative position from 0 to 4 and 5 to 10, just to kind of get you thinking about negative position. And then when you're done, draw a graph that is increasing from -7 to 2, decreasing from 2 to 7, and then constant the rest, but it always has a negative position. So you could be creative with it. There's an infinite amount of right answers, but just try and draw something. All right, so if you draw the first one, it's negative position from 0 to 4. So essentially 0 and 4 can be x-intercepts. And then 5 to 10, something like that. So it's going to be positive s. So if I could just actually make it look like a polynomial. And then negative position from 0 to 4. So now it's negative from 0 to 4. Have a slide back up and then go back down between 5 and 10. And then, that's a typical graph. Yours could have looked very different, but just kind of be able to see the negative position from that. Here, a graph that is always, so increasing from -7 to 2. Actually, I'll just use this graph. So if I have like -7 here, and this is 2. So it is increasing from -7 to 2, but it always is negative position. So I want to make sure I stay underneath the x-axis. So -7 to 2, and just draw a straight line, right? That's still negative position, but it's increasing over that interval. Decreasing from 2 to 7. So this is 2, make this 7 here. So I can just be decreasing from 2 to 7, and then just constant the rest. So I could just make it look like that. And that fits. That always has negative position. So that's it. I know it's a longer video, but now that you're done, you might as well just start the homework and bring any questions that you have with me for next class, and then we'll try and go over it before we start the day 2 stuff.